Okay, so today we'll be looking at its intro to data preparation using Python, and we'll be using this in knowledge to actually prepare data for machine learning models and also use this for data analytics. You can also use this just to prepare data in general. So the essence of data preparation is that we want to just know that a function exists. Because memorizing function names is hard, let's say you are working with 3 different programming languages, they could have programmed the function names as something as different as, let's say I want to, flip a data frame. It could be named as flip. It could be named as turn. It could be named as transpose. Well, transpose is the most common one. Let's say they don't know the actual name itself. They will use some other function name. So we just want to know that a function exists. That's where we can actually use all of this knowledge to Google it so that we can actually get a specific function that we want. So for importing and exporting a CSV, let's say a CSV is a comma separated value. So let's say you have this data here. I just want to separate it using commas so that when we extract it into Python, it will be retained as a table. So let's say I have a name that has a comma in it. I wouldn't want to use a comma. I would use something else, let's say a bar or something like a tab. It can be anything as long as it's unique and it doesn't disrupt data, basically. The essence of data preparation is Googling. So we just want to know that this function exists. That's where we get this read CSV from Python. We also have write and export CSV. A data frame is a 2D structure. That's why we have a table. That's why all the CSV files are just 2D. The main trait of a data frame is that each column or each series can only hold one type of data. So height, 5.5, 8.8, 9.0. Location, it can be a string. And if you want to put 3 in here, it has to be a string. So it has to be a string 3 instead of just the number 3. It can be any data type as long as it's consistent within the series itself. And we're going to start off with selecting. Selecting means you just want to select a specific row, a specific cell, a specific column. So let's say I want to select column A. Sometimes they will say series A, so DFA, and if you want to select multiple, you can say DF double brackets A and B. And note that you can actually replace B with D in order to select A and D at the same time. It doesn't have to be next to each other. So let's say I want to get a specific row, a row of 0. I mean the row index 0, maybe the first row. You want to select multiple, you do the same thing. Note the double brackets. Let's say I want to select a specific cell, you have to do 2 of these operations at the same time. So we start with the first example here, which is df index location of 0. That means we get the first row. Then we double bracket A and B, in which we just select the first 2 columns. We can do it differently. We select the first 2 columns here, and then we select the first row. So these 2 operations end up with this. Now we'll be looking at splitting. It's quite self-explanatory. You just split by the underscore here, and then the operation is a little bit complicated, but you can Google it and you can just replace some of the variables with your own, and then you end up with this. It's a little bit complicated to really explain in depth. So what you're going to look at is this thing here. This thing is called a name parameter. This means that n equals to 1. That means I want to specifically tell Python that n is equals to 1 and expand is equals to true. I'll show you. So let's say you have a box volume of xyz. So let's say you have a function that returns the box volume xyz, and then you just multiply all of them together. So box volume 1, 2, 3, it just returns you 1 times 2 times 3, which is 6. You can specify which one is x, which one is y, which one is z. It returns the same thing. And note that with a name parameter, you don't have to follow the naming convention used in the function itself. And the thing is that if you have something that is a default value, you just want to avoid that default value, you just want to get the last parameter, you can just directly name it using that particular parameter. So what we'll be looking at is aggregating. aka group by. So let's say I want to group by this data set by area code and sum everything. I just want to sum up all the account lengths that have area code 415 in it, and we want to also group by the other area codes. Well, you can actually do that. So let's just look at 415 first. We eliminate everything else that is of not area code 415, and then we sum them up. Note there are things that you cannot sum up, like strings. You cannot sum up booleans, therefore it will eliminate all of these columns, and we will just only sum account lengths. So let's look at the other area codes also. We have the area code 408, it just has one data, and 510 we are just summing up all of the other account lengths. And then after we sum them up, we have this particular data frame that we can actually look at. So we'll be taking a look at another example of aggregating. For this one, we'll be looking at grouping by state, and they want to get the maximum of everything. So let's see how we group by states. KS is grouped KS, OH, OK, and MO. We're going to filter out all the values and then group them into one. We're going to remove all of the empty rows, and then we're going to get the maximum. So for this KS example, the account length maximum is 137, area code is 415, and the maximum of no and no is no. So let's look at OK, maximum 121, area code maximum is 510, and yes is no, the maximum is yes. So what we can get is this particular data frame. Okay, so for this, what we're going to look at is the Jupyter notebook for my intro to data processing using Python. And I hope that you have tried it out. If you haven't, that's fine. We'll be going through everything, but it will be slightly faster than usual. So for dataset, we'll be looking at telecom churn.csv, and we want to firstly import pandas. Pandas uses this read CSV in order to export this as a data frame. So it is as simple as loading pandas and then just use pandas to read CSV for this telecom churn. So if you have tried it out, if you print df, it's going to look really ugly like this. So the remedy is to not print it like this. Instead, you just print it using df, or you can print it using df.head. df.head means you want to get the first 5 rows. You can also specify 10 rows, you can specify 2, and so on. But by default is 5. We use this just to get a really quick glance on the data frame without having to print out everything. So let's say I want to select a column. So for example, I want to get something else. Let's say the total night charge, which is right here, the total night charge. So we just type in total night charge. Note the capitalization, it matters a lot. So you get this. And then if I want to get more, you can say head.10. So by default, this chunk actually holds all the data. If you just press .head, it just gives you a part of the data. So if you want to get everything, you just have to not specify the .head. It will give you everything. Right? So let's say I want to select a specific column, a specific row, select 3. So you expect OH, 84, 408, and so on. So df index location 3. And then we want to get the first 3 items. We just type in head 3, and I get OH, 84, and 408. So let's look at this tutorial right here. Get the states and area codes of the file. We also want to know if the customer is churned or not. Can you also export it? But we have to remind ourselves what is the data. So we want to get the state. We also want to get the area code. We want to get the churn. So the churn is at the very back. And then we want to get multiple columns, right? And then we get the head just to make sure it's correct, right? So we get the correct columns and then we export it to CSV. If you Google it correctly, to CSV. And then just type in out CSV, right? So we can test it out if it has worked well or not. So you'll notice that there's this thing called unnamed 0, 1, 2, 3, 4. What happened was that when you export it out to CSV, it also exported out the row the row names here. So 0, 1, 2, 3, 4. It doesn't mean anything, but it also exported it out. So what you can do is you can type in index false. That means it just doesn't export out the index. So now it works fine. So the next one we're looking at is splitting. Splitting is a little bit harder because it uses quite a complicated structure. But what you can do is you can just Google it, and then you get this kind of format. So you want to find out how to actually use this format into your data preparation, and then you have to modify. So let's get DFA, column to split. What's the column you need to split? Name, age. You split by this underscore, and there you go. You actually split it like that. As simple. Okay, so next one. So there are some common examples on like, okay, what's the average account length for each state? What's the most common area code? And so on, right? What these questions entail is aggregation. So we're going to try out how to answer all these things here first. What's the average account length for each state? So we can do df.f, group by state, and then average, which is mean, right? So this one gives you the average count length for each state. It also averaged the area code, but we can remove area code by just typing account length, right? So you get the account length only. And then let's say we want to find out what's the most common area code. So what that means is you just group by area code, and then we count. So how much occurrence of area code has occurred in each. Yeah, so quite simple. So there are a lot more examples that you can look at here, just to facilitate facilitate your understanding. So what we're going to jump into is tutorial 3.3. So let's say we want to get the state which has the least customer service calls based on the data. So what you can do is you can recap the data here, df group by and state. And then we want to sum everything. Well, we just want the customer service call, so we can just extract this particular column using customer service calls. And that's it. You can find out all of these data, but it doesn't seem to be sorted, which is something that we might want to have. So you can say sort values, and then you get everything here. So the next topic we're going to look at is unique. Unique is quite self-explanatory. It means I want to get the unique of something, the distinct values. So for example, I want to get what type of area codes there are in the whole data frame. That means I want to get dfg area code unique, right? So it just gets all distinct area code values of the area code. So you can also apply to rows also. Let's say you have multiple repeated rows. You want to get just one repetition of that. You can just call unique on it. So let's say I want to get get all the unique states. So I can just say df state unique. Very simple. You get all the unique states like that. Okay, so this is going to be the last topic, which is joining. So joining is useful if you have two tables that are somehow related. So let's just look at these two tables. The first table is DFH, which is a shopping list. So let's say you have item ID of 1 and you have 1 of item ID. That means you label it by ID. So the second one is the database. So you have the item ID 1, 2, 3, item name, and the cost itself. So what joining does is that it joins these two. So let's say you have count of 1, item ID 1. It just joins with item ID 1 here, right? So 1 count of choco of 34.4. 32, item ID 3, strawberries 62.4. And there's a problem because we have 18 and 4, which doesn't match anything, and we will see how this actually works later on anyways. Basically, what you do is you merge these two together. So what you have is the first item ID, and then the third item ID. The fourth one is excluded because it doesn't have a specific value here. So there are different kind of merges, and this merge is what we call an inner merge. So the different merges uses left, right, and method. It means that this is relative to how you actually merge it. So let's say you have DFI, DFH. If it's a left join, that means I want to keep all the left entries. That means the left entry DFI, which is this database, I want to keep all of it. So if I want to keep all of this database, we can use the left join. So if there's a non-existing entry here, it will say NaN. This is the right join in which it keeps the shopping list. So because the shopping list has this item ID 4 and the database doesn't have it, it means it will show an NaN, which is not a number, right? So now you have the outer join. The outer join just keeps everything regardless of if it has a specific entry later on. An inner join is what we have done right here. It's just implicit. So it just joins everything without the missing entries. Okay, so this one will be the last tutorial, and we'll be looking at something quite complicated actually. There's a lot of steps that I actually skipped in data processing. You can actually try to find out all of these other steps I'm going to utilize later on, but let's look at the tutorial first. So first things first, I'm going to look at what these data frames are. So we have DF order and we have DF company. So it seems like we have to merge these two, right? Deliverable ID and deliverable ID. And then we try to multiply counts with cost. So we will worry about how we can actually multiply the counts and how do we filter out the confirm later. It's going to be a technique I haven't taught yet. So first things first, we are going to merge. So, right, this deliverable is spelled incorrectly. You can't really tell from here actually, but if you specify it, so let's say left on, that means I want to specify what is the deliverable ID column and write on deliverable ID, it will work. And it splits into two different columns. But the thing is that this one is just spelled incorrectly. Let's say you keep on getting this order that is spelled incorrectly. You don't have to manually keep on just changing this. Sorry, this one is yeah, like that. It was like that. So let's say you have an order that just like shows up like DLID. You don't have to keep on changing it. So you can just leave it as is. And then you can say DLID. I'm just going to run it just to show you. Right, DLID. You can do this and it'll still work. So you don't have to worry about if you need to change the actual column name to keep on fixing this. So the next part is to try to multiply these two. And as you expect, you can actually do multiplication. So I'm just going to save this into DataFrame. We'll just call it AA. Print it out just to remind ourselves. Right? The FAA, what you can do is you can create another column called C count, I guess. It can be any. So DFAA count multiplied by DFAA cost. So let's look at DFAA again. Now you have this C count right here, right? So what you need to do is you need to remove this confirmed that is false. What you can do is you can do something called a mask. It's something like filter, but it looks really complicated. So what it does is that it finds out all of these that are true and false, and then it says that, okay, if it is, it just takes this mask, that means it uses 0, 1, 2, and 4, it removes 3, and then it just splices it like that. So you have this output that removes the false. You can also just remove this true. It still works. It's just for syntax. I mean, it's just to make it clear, right? You can also try to select it if there is very little columns. It works as well. So DFAA, DFAA, and then we can just save it back to DFAB just to make it different. And then now what we need to do is we need to sum this. So in dfab, we get the C count, get the sum, and that's it. But there's a lot of operators, there's a lot of functions that you can use in Python that I have not taught. So there is a lot of things that you can learn from this. So yeah, as you can see, slicing, transposing, filtering by values. This is filtering by values. Handling missing values is also quite important. And all in all, there's a lot of things that I haven't covered here. If you're just, focusing more on machine learning, I think these basics are fine.